Today we're going to be using the triangles that we've proven congruent to then state that other parts of our congruent triangles are congruent. And we're going to be using this concept of corresponding parts of congruent triangles are congruent. So our first proof says that segment PR bisects angle QPS. And PQ is congruent to PS. I need to prove that angle Q equals angle S. So before I even start that, let me mark up the diagram. So if I have PR bisecting QPS, that means angle 1 is equal to angle 2. And we're also given that PQ is equal to PS. Then we know PR is equal to itself. So then I can say my triangles are congruent. And notice how angle Q and angle S are corresponding parts. So then I can state the corresponding parts of congruent triangles are congruent. So let's write out the formal proof. So PR bisects angle QP S, that's a P. Let me make that look a little bit more like a P. And we also know that PQ is congruent to PS, and we are given that. So let's take this first piece of this given. PR bisects angle QPS. Now I can state that angle 1 is congruent to angle 2 by definition of an angle bisector. Then we can say PR is equal to PR by reflexive. Now my triangles are congruent by side angle side. So triangle RQP is congruent to triangle RSP by side angle side. And let me highlight those pieces of our proof. This was one of our sides, this was our angle, and this was the other side. So think about it like, again, a checklist. I have all those three things listed in my proof. So then now, angle Q is congruent to angle S because of corresponding parts of congruent triangles are congruent. Our next proof. WX is congruent to YZ. ZW is congruent to XY. So our first step, we're given WX congruent to YZ, and ZW is congruent to XY, and we are given that. Now we have the common side equal. So our second step would be ZX is congruent to ZX by reflexive property. Now we have our triangles congruent. Now let's talk about what I'm trying to prove. I'm trying to prove WX is parallel to YZ. Remember, the only way that we can state that lines are parallel is if we get one of our special angle pairs, congruent or supplementary, depending on the special angle pair. Notice how when you look at this, angle 1 and angle 2 would be our special angle pair. So we need to get angle 1 and angle 2 equal. So I'm using the fact that we now have congruent triangles. So triangle ZWX is congruent to triangle XYZ by our side, side, side. So now that I have that, we can then state that angle 1 and 2 are equal because those are corresponding angles. So angle 1 is congruent to angle 2 by corresponding parts of congruent triangles are congruent. And then because I have angle 1 and angle 2 are alternate interior angles, I can say WX is parallel to YZ by alternate interior angles congruent is going to give me parallel lines. Okay, our next proof. And yes, this is a proof heavy lesson. I apologize, but what are you going to do? First, we're given AB and DC bisect each other. And we're given that. So now, again, we're trying to prove AD is parallel to CB. So if we get one of our special angle pairs equal, so for example, angle D congruent to angle C. So it'd be nice if I could get these two triangles here congruent. So if I get those two triangles congruent somehow, so take something from your given. Again, I always say that to help you out with proofs. Take something from the given. So if we bisect, that means that M is the midpoint of AB and DC. And that's by the definition of a segment bisector. And a lot of students get this step wrong in the proof. They forget that M is the midpoint. When you talk about a bisector, first you have to state then it's the midpoint. Then you can say the step that all you guys want to say, that AM is equal to MB and DM is equal to MC by definition of midpoint. So you need that definition of a segment bisector first, because it doesn't say that it's a midpoint. It doesn't say M is the midpoint. It says that they bisect. So then you need to tell me what the midpoint is. Then you can say that we have our congruent segments. And let me mark those up for you guys so you guys can see that now all I need to do, and I'm going to throw in some angle numbers, is state that angle 1 is congruent to angle 2 because our vertical angles are congruent. Now that I have my vertical angles congruent, I can say that triangle AMD is congruent to triangle BMC by side, angle, side, and again highlighting those. We have side here, we have the angle with angle 1 and angle 2, and then we also have the other side listed here. So we have side, angle, side. Now, pick a pair of alternate interior angles. D and C are alternate interior angles, or you could use A and B. I'm going to use D and C since that's what I marked earlier in the proof. Angle D is congruent to angle C by our corresponding parts of congruent triangles are congruent. Now that I know that, I can say AD is parallel to BC by alternate interior congruent is going to give me parallel lines. Okay, there are your lesson questions. So for the first one, you're listing the order of the correct statements. For part 2, you're listing the order of the correct reasons. And I give you guys an example down here. And these aren't necessarily the only option that you have. So if you think that you have a different option, you can always ask me and figure out which option is, if your option works. And please make sure that lesson summary is submitted on time.